Okay, so we just finished our series of labs over shear wave inspection. We used a dual element transducer. This lab, I'm just going to put this right on top of here. We're going to do calculate the velocity in a material. So lab number 12 of your packet. I went back to a single element transducer. So we need to turn the single element off. Go to pulsar, turn our dual off. We have a 2¼ megahertz, so let's go to receiver. We're still there. Go back to our base menu, bring our probe delay all the way to 0. Go to regular velocity, compressional velocity. If I could get it to stay in one spot. Once it starts moving, it moves fast. So 230. We have a 1-inch thickness, so I'm going to go to about a 1-inch screen. Yeah, 1-inch screen will be fine. 1-inch thickness. We're going to take our velocity, ring it in a little bit. You can do this with a 5-inch screen, 4-inch screen, whatever, but since I know both of these pieces are 1-inch steel and aluminum, we're just going to use that. That makes it a little bit easier on us. So, got a 1-inch. Zoom in a little bit there. You see our 1-inch range. Yep, there he is. There's our piece of aluminum. Here's our piece of steel. Okay? No coupling between the two, so our air back wall is going to help us out here. So, back up so you can see the transducer on the piece of steel. Coming up at 100%. We're going to go here to our piece of aluminum, 1-inch thick, and it's going to come up at about 94%. So that tells us the velocity is a little faster in the aluminum. So using lab number 12, it says, you go all the way to the bottom, you can read the top stuff. It says, now, calculate V1 times T1 divided by T2. So velocity 1 is 0.23 times 1 divided by 0.94, because that's what it shows on the screen, equals 0.2446. So if we were betting, we would say 0.246 or 244. That's pretty close to 0.25. So we know that this is steel, this is aluminum. But what we actually did there, really more than anything, is figure out that if we were scanning a piece of steel and then all of a sudden we had a velocity change and we know the thickness is still the same, but we had a velocity change and our signal changed, we could say, okay, now we've got a problem. We know that we're not on steel anymore. So really, that lab is pretty simple. All you're trying to do is calculate from one velocity to the other, which shouldn't be much of an issue. And you can do that on anything. Okay? So, here's our piece of steel. We got 1-inch. Come over here, we know that's 0.625. So we come over here, we know it's way past an inch. Alright, so now we go to our aluminum again, and it's coming up at about 94% one last time. So we can figure out real quick that V1 times T1, velocity 1 times thickness 1, divided by thickness 2 equals velocity 2. Okay? Any questions there? You should feel free to ask. And I'll let you take a look at that. Just kind of soak that in one last time. Kind of zoom in a little bit there so you can see what we're talking about with our 94%. And from that, like I said before, any questions, feel free to email me.